So here the question is to find Taylor's quadratic approximation. So for that you need to find the first order derivatives and second order partial derivatives. So I hope you can see that the function is square root of x plus y, and first I need to find the value at 1 3, so which is root 4 and which is nothing 2. And I already found first order partial derivative. I hope you can actually write it like x plus y whole power 1 by 2. Its derivative is 1 by 2 into x plus y whole power 1 by 2 minus 1. That's what 1 by 2 root x. Okay. Simply the derivative of root x is 1 by 2 root x. Using that you can easily write this. So when you substitute the point here, 1 over 2 times root 4, so that becomes 1 over 4. Even this also becomes 1 over 4. And the advantage with this function is it is actually symmetric about x and y. Okay, if you replace x with y, y with x, you'll get the same function. So in that case we have an advantage. Fx and fy both will be equal. And not only that, all second order partial derivatives will be equal. Okay, if you have doubt, you verify. Fxx, fxy, fyy all will be equal, and that is equal to 1 by 2 times of, and this one how do you write? X plus y whole power minus 1 by 2, right? 1 by root of x plus y can be written like this. So its derivative will be minus 1 by 2 times of x plus y whole power minus 1 by 2 minus 1. And the derivative of x plus y, that is anyway 1. And which equals what? Minus 1 by 4, which is actually x plus y whole power minus 3 by 2. Okay, so let us find the second order partial derivatives at 1 comma 3. So at 1 comma 3 what happens? This equals minus 1 by 4, this is 4 to the power of negative 3 by 2. I hope you can see that is minus 1 by 4 times 1 by 2 cube, that is 1 by 8. Okay, so you'll get minus 1 over 32. So you got the second order partial derivatives, you got the first order partial derivatives. Now we are ready to write linear degree approximation. So sorry, not linear, quadratic approximation. So the q of x comma y. So f at the given point, f at so first let me write the formula, that is f at 1 3 plus x minus 1 times fx plus, and you know this is y minus 3 times fy, yeah, and you're going to take the partial derivatives at 1 3, okay, plus 1 by 2 factorial times x minus 1 whole square, and you'll take fxx, and plus 2 times x minus 1 into y minus 3 fxy plus y minus 1 whole square times fyy, and you're going to take the partial derivatives at 1 comma 3. Okay, so therefore q of x comma y after substitution of all, so what do we got here? This is 2 on 1 by 4 on 1 by 32. Okay, so this is 2 plus, you know, fx and fy both are equals to 1 by 4, so let me take it out. So this is x minus 1 times, sorry, x minus 1 plus y minus 3. And even the second order partial derivatives all are equal to 1 over 32. 1 over 32 times 2, times 1 over 2, you'll get 1 over 64 times the 1, x minus 1 whole square plus 2 times x minus 1 into y minus 3 plus you have y minus 3 whole square. Sorry, here I should write y minus 3. I think I wrote it 1. Okay. So this is the quadratic approximation. Now you can simplify this and finally you can obtain q of x comma y. Okay. So now let us go for the second part. So what is the second part? Find the maximum error in this region. So let me take this region here. So the given region is this one. So since you are taking quadratic approximation, you know the in the quadratic approximation the remainder term is less than or equal to, so m by 3 factorial into delta 1 plus delta 2 whole cube. Okay, where m is nothing but where m is maximum of maximum of absolute value of third order partial derivatives, and you need to mention all third order partial derivatives here. Okay, so here the advantage with this problem is it is symmetric about x and y, right? So the all third order partial derivatives here, that would be equal to, first of all let me see what is the second order partial derivative, minus 1 by 4 times this, right? Therefore, which is minus 1 by 4 times, you know, this is minus 3 by 2 times x plus y whole power minus 3 by 2 minus 1, and that's what exactly 3 over 8, and this is x plus y power minus 5 by 2. So you can rewrite it like this: 3 over 8 times of x plus y whole power 5 by 2. So this is what the third order partial derivative. Even if you look at fxxy and fyxx, these are all equal to the same thing. Okay, so these are all equal to the single expression. So now it is enough to find maximum of this function, maximum of this expression over the given region. Okay, so let me take that expression. So now it is enough to concentrate on this function, which is 3 over 8 times x plus y whole power 5 by 2. Okay, so let me look at the given region here. So what is the region? Mod x minus 1 is less than 0.2. I hope this mod x minus 1 less than 0.2 can be rewritten like this: minus 0.2 is less than x minus 1 is less than 0.2. So adding 1, you'll get 1 minus 0.2 is less than x is less than 1 plus 0.2. So therefore you have 0.8, which is less than x is less than 1.2. So what it says is, in the given region, x maximum value is 1.2, minimum value is 0.8. And similarly we have one more expression. What is it? Okay, mod y minus 3. So mod y minus 3 is less than, it's given 0.1 here. Okay, so do the similar things. I hope you'll get this. This is 2.9 is less than y is less than 3.1. So now in this region you need to see the maximum of this one. Okay, and when is it going to have maximum? Suppose if you substitute these higher values 1.2 and 3.1, this will give you minimum of it. Why? Because the expression is there in the denominator. The expression is there in the denominator. Okay, let me explain simply. Suppose if I take 1 by x over the interval some 3 comma 4, where will it have maximum? When you plug in 1 by 3, you'll get 1 by 3. When you plug in 4, you'll get 1 by 4. Which is maximum? This is maximum. Okay, so therefore, so when you plug in the minimum values in the denominator expression, you'll get the maximum of the function. So therefore, so let's write what is m here. So m would be 3 by 8 times, you know, 1 over 2 point, okay, first let me substitute x, 0.8 plus 2.9, okay, whole to the power of 5 by 2. So this we need to compute. Okay, so that's what exactly 3 over 8 times 1 over, so you just need to add these two, that will give you 3.7 whole power 5 by 2. So if you compute it, so which you'll get 0.01424. Okay, so this is m, it's not the maximum possible error. Okay, you got m. So now you need to substitute this m in this formula. So let's write it. So therefore R2, absolute value of R2 is less than or equal to m value we got 0.01424. Okay, so this divided by 3 factorial is nothing but 6, and delta 1, what is delta 1 here? So you can see that delta 1 is 0.2 and delta 2 is 0.1. Okay, so which is 0.2 plus 0.1 whole cube. So now all together we need to compute this. So this you will get it like 0.00006408. Okay, therefore, so here we can claim that error would be less than or equal to this one. So because this is the maximum possible error in the given region. Okay, so when you round it, you can write this. Yeah, so we can actually see the given answer. So the given answer is this. So I hope we got everything, and this one they consider just 0.0142. Okay, and the error is less than this, and that's what exactly we got it, right? Why? Because we can even rewrite it like this, you know. So this one you can write it like 64 times 10 to the power of negative 6. Even this you can write it as 0.64 times 10 to the power of negative 4. Okay, we got the same thing, not the different. Okay, so I hope you understand. Thank you.